We have the question here. F of x is 2x minus 1 squared x plus 1. Find the critical points, determine the nature, state the function, determine why it's increasing and decreasing. But find the critical points, we have to differentiate the function and declare the derivative to 0. So the best way here to integrate and to differentiate the function, if you want, you can differentiate like this and use product rule. But because of the part which says that we should sketch, and the fact that we have differentiate files, well, maybe we can do the expansion just here before we differentiate it. So expand 2x minus 1 multiplied by itself, and then multiplied by x plus 1. We're trying to attend to the square. So 2x times 2x. 2x times 2x, we get 4x squared. And then 2x times 1, we get 2x. Then we get minus 2x. I mean. We're doing 2x times negative 1, so we get minus 2x. Minus 1 times 2x, we get minus 2x. Minus 1 times minus 1, we get positive 1. This whole thing we have multiplied by x plus 1. So 4x squared minus 4x plus 1. And now we multiply by x plus 1. So 4x squared times x, we'll get 4x power 3 plus 4x squared. Minus 4x times x, we get minus 4x squared minus 4x. 1 times x, we get x. 1 times 1, we get 1. So this function, f of x, can be written as 4x to the power 3. This is 0 here. So we'll have minus 3x and then plus 1. It's the function that we have. So to find the critical points, we differentiate this function. We're now answering question 1. So we differentiate f. We get 3 times 4. That is 12x squared minus 3. After that, we equate the first derivative to 0. So we get x squared is equal to 3 over 12, which we know this is x squared is equal to 1 over 4.
Yeah, Zoom imeshtaki tafuta mimi na uyaziko madeni sasa kama tuitoe.
And then you square root.
Mama, leave me here.
So in square root, we get x is equal to 1 over 2. So x is negative 1 over 2. So these two values of x are the ones that are giving us the y coordinates. Then together will form the critical points. So a point is x comma y. What we have here is just x, so we need the y part. So how do we get the y part? You get the y part by substituting the value you have in the original function. So we have 4, and then half to the power 3 minus 3 multiplied by half, and then plus 1. So that we get 4. 1 to the power 3 is 1, and then 2 to the power 3 is 8. And then minus 3 over 2 plus 1. If we get 8 in the denominator here, we have 8 into 8 itself, we get 1. So we get 4 minus 2 into 8, we have 8. We have 4, 4 by 3, that's 12, and then plus 8. So 4 minus 12, that's minus 8. Minus 8 plus 8, we get 0. This is 0 over 8, which is just 0. This means that we have a point half, comma 0. Then we also pick negative half, looking for the y value and substitute in the function f. And that is, we have 4, and then minus half, the power 3, minus 3, minus half, and then plus 1. This will give us minus 4 over 8, and then plus 3 over 2, plus 1. Well, I may choose to reduce this because I know 4 can go in 8 twice. And then I have this, and I have that. I also know that if I say 2 is a common denominator here, then we have negative 1 plus 3, and then plus 2 itself. 3 plus 2 is 5, minus 1 will get 4, over 2, this is 2. So we're getting another point, that is minus half, comma positive 2. These are the critical points. When I have the critical points, the next question is, are you able to determine the nature of this critical point?
So, I've got a question. The last time you were solving this question, you said you have to replace in the real equation. Now, today you're replacing the differentiated one. Is it the same or it's different?
Which one is the differentiated?
This no.
So to determine the nature, you differentiate the first derivative to get the second derivative. That is 24x. And then in the second derivative, you substitute the point. The point is x comma y. If I have y, I'll substitute the point. But if I have x, I'll just substitute the x that I have. So I expanded the equation for easy calculations. It's not like using power law is going to be easier as compared to using product differential. Because I knew how to differentiate the function. Go ahead. I also knew that I had to equate the derivative to 0, so that's why I was quick to expand it. So in the second derivative, you pick the point. So in this case, we're picking the value of the point that has half comma 0 and substitute what is x that we have. This is going to be 12, which is greater than 0. That means that the point that we have is called relative number. I also get the second derivative again. You can have that. So you get f prime prime and substitute negative half. And then you have 24 and negative half. This is giving us negative 12, which is less than 0. That means that this is relative maximum.
So repeat the statement after finding the 12.
If the number you get is positive, the point is called the relative minimum. If the number you get is negative, point is called the relative maximum. So we have determined the nature.
Sorry?
If the second derivative, when you substitute, you get a positive number. It means that the point is called the relative minimum. If the second derivative gives you a negative number, then the point is relative maximum. So what we have here as relative minima and relative maxima are turning points. Part 3 says sketch the function. So to sketch the function, what we need now are the intercepts. So we'll come back here and sketch the function by simply looking for the intercepts now. So we look for the x-intercept. For x-intercepts, we equate f to 0. We're not going to equate this one that you have expanded. We equate the one that is factorized. So say 2x minus 1 squared multiplied by x plus 1 is 0. This means that x is negative 1 and also x is positive half. So we have two intercepts there. Yes. When you equated the first derivative to 0, these values of x here are called critical numbers. What does the question say? The question says find the critical points. So you use your critical numbers to substitute in the original function so that you can get the y coordinates. So you can make critical points. So after you equate the function to 0, we've gotten these intercepts here for x. Well, we also need to get the y-intercept. How do you get the y-intercept? Where there's x, you put 0. So we have negative 1 squared multiplied by 1, which is positive 1. So the point is 0, 1. Let me sketch it. The turning points, negative half, 2. Here, we also have a half, 0. There, and half, 0 is minima. So it means that function will just touch there, go up here. The intercept we have negative 1 and half. The y-intercept is positive 1.
Sir,
Mhm.
sir, repeat some there. Where you're doing the dark, from the y-intercept.
The y-intercept, you just substitute where there is
Going
x, you
down.
put 0.
And then how is it now 0,1?
What equation have you used to find the y-intercept? To find the y-intercept, you use the function equation. The function that you're sketching is the one you use to find the y-intercept. We're not sketching the derivative here, we're sketching the original function f.
What of the turning point?
The turning points are the turning points of the curve that you're sketching. Not the turning points. They are not the turning points of the derivative. They are turning points of the function f. Why is it 0,1? If I get 0 and substitute where there's x, the number I get is coming to form a point. It's a y coordinate of 0. F of a is equal to b. This means I have a point a comma b. That's why we say 0,1 is the y coordinate. I mean, it's the y intercept. What you call a turning point, used as a turning point. So because we have half comma 0 the turning point, so the curve will turn there. How are you finding the turning point? You differentiate the first derivative and equate it to 0. You get the x numbers. The x numbers you get, substitute them in the original function to get the y numbers. Then put the x number, comma the y number. The x number, comma the y number. Then you have points. These points are called turning points.
So, sir, the critical
Sir?
points are the turning points.
Yes.
So when finding the turning point, can you use that formula x is equals to negative b over 2a?
If it's a quadratic.
All right.
Determine the interval in which f is increasing. From the sketch, f is increasing on, why is the function increasing? When they say determine the interval where f is increasing, they mean find the x values where the curve is going up. The curve is going up here. The curve is going up here. There the curve is pointing up. That is where f is increasing. What values of x is a question for you. So values of x from negative infinity up to negative half. Union positive half up to positive infinity. The function is going up. The function is going up. That is where it's increasing. F is decreasing where the function is going down. The function is going down. What values of x from negative half up to positive half? When they say find where f is increasing, you are finding where f is going up. F is decreasing, you're finding where f is going down.
Sir,
Hello.
Why didn't you start from -1 to why use infinite?
Because the function goes beyond -1. This curve can keep going. -1 is just the intercept. B, part 1, let A be equal to the matrix 1, 0, 2, 3, 1, 0, 1, -1, -2. Find A inverse. Find A inverse. To find the inverse, the formula for the inverse is 1 over the determinant of A multiplied by the adjoint of A. To find the adjoint of A, you get the cofactor matrix of A and transpose it. So we start. What is the determinant of A? The determinant of A, you pick either a row or a column. So if I pick the first row, then I'll get 1. Remove the column and the row. The remaining numbers, I get the determinant. So we have 1 times -2, like this, minus -1 times 0. So 1 times -2, we're getting -2 minus -1 times 0. Now we're getting 0. So the answer here is -2. And then minus from the plus, minus, plus, we get a minus. Pick the number 0. Oh, but because the number is 0, I don't need to find the determinant to multiply by 0 because I know even if I multiply, it will be 0. So I'll move on to the next number, 2. Remove the row and the column. Then calculate. So I'll have 3 times -1 plus -3 minus 1 times 1, that's 1. So -3 minus 1, that's -4. So that we get -2 minus 8, which is equal to -10. So the determinant is -10 here. And then we now find the cofactor matrix. The cofactor matrix of A is a matrix that respects the invisible signs. Minimum, so plus, minus, plus, minus, plus, minus. plus, minus, plus. In the cofactor matrix, we're not using the position number. When getting the determinant, we're also multiplying by the 2. As you can see here, multiply the 2 by the determinant. But this time around in the cofactor matrix, you're only interested in the determinants. So when I go to 1, I'll remove the row and the column and get the determinant for inside. That is -2 minus 0. So we are getting -2 here. The next number, we remove the column and the row and get the determinant of the remaining numbers. So 3 times -2, we get -6. Minus 1 times 0, that is 0. So we have -6. And then, all right, we have -6 here. And then we remove the column and the row for 2. So we have -3 minus 1, that's -4. So we have -4 here. And then the next, we remove the column and the row. So we have 0 minus -2. So it becomes +2. And then we remove the column and the row. So we have -6 minus 0. So it becomes -6. And then we remove the column and the row. So we have -3 minus 1, that's -4. Then we remove the column and the row. So we have 0 minus 2, that's -2. And then we remove this guy and this guy. So we have 1 -6. Then we have 0 minus 6, which is -6. And then we remove this guy and this guy. So we get 1 minus 0, which is 1. And then to get the adjoint matrix of A, we transpose this matrix. To transpose, what were rows will now become columns. So what were rows are now becoming columns. So we have -2, +6, -4, -2,
So I have a question.
-6. Hello.
Yes, so when you're finding the inverse for the matrix, like the first inverse we're finding, we're only considering the signs on the first row, or it has to be everywhere in the matrix?
Everywhere in the matrix.
Not when finding the cofactor, but the inverse for the first one.
The determinant.
Are we supposed to yes, but when you find the determinant for the first matrix, and we're supposed to consider the signs for all the numbers that are inside, or it's only the first row?
Only in the first row. If you pick the first row.
Okay. Okay.
So then we have -2, +6, +1. So somebody says, can we please go through the second row? The second row is here. How did we get it? We cut this and cut this. Then we have 0 minus -1 times 2. So that is 0 minus 2 minus -2. So it becomes +2. That's why we have the 2 here. And then you remove this and you remove that. Then you have -2 minus 2. That's minus, you see, we remove that. So we get -2 minus 2. So we get -4. So this should be -4. Okay, yeah, you're right. So where was that? Okay, we'll follow it up. And then the last one is we cut this, we cut that. Then we have -1 minus 0. Okay, what does that mean? So we get minus. I correct it goes. This was 4. And this is now 1. Yeah, minus 1 minus 0. Okay. So when we write them here, that will be these, which are making the second column. So this is 4. And this is 1. This is 1. Okay, thank you. So to get the inverse now, we have A inverse is equal to 1 over the determinant, which we got as 10. So we have 1 over negative 10 multiplied by this adjoint, which is negative 2, negative 2, negative 2. And then 6, negative 4, 6, negative 4, 1, 1. So this is the inverse.
So it's okay if you leave it like that, or maybe you have to complete it. It's mandatory.
Leave it like that. This is complete. This is complete.
So what she means is that you divide negative.
In mathematics, everywhere there's anything common, we factor it out. So that being factored out is the formula of living.
So I'm saying the final answer.
Uh-huh.
I'm saying the final answer you've written there, the A inverse we found.
Yes.
I'm saying, do you have to finish it, or maybe it's okay to leave it like that, the way you've left it?
When you say finish, what do you mean?
Maybe you have to multiply the 1 over 10 by each one of the numbers in the matrix.
So that's why I'm saying that this is complete the way it appears like this. So we have finished it.
Sir.
The multiplying inside does not change anything.
Sir.
Hello.
Yes, I wanted to ask on the first part while we're getting the determinant. Is it always that you need to do the row by column, or you can just get the 2 columns, then you add them? Then I don't know if you know you're aware of the formula that I'm talking about.
Yeah, whatever method you use for that to get the determinant.
Okay, thank you.
So,
Hello.
me, I usually get confused, like when finding a determinant, say if you have -1 on the first row, then since we start with positive, so do you multiply the signs or what?
You multiply the numbers when they meet like that. Here we had 1, isn't it? So you multiplied 1 times -2. If we had -1, that multiplied -1 times -2. So you don't talk about the signs, you just work out. The signs will pass out on their own.
No, sir, I mean like there if we had -1, where there's +1. In the first, which row, column? Row.
If this was -1.
Yes. How can you work it out now? There, since there we follow positive, negative, positive. So are we going to multiply? Since it's positive, we follow the positive sign. Are we going to do positive
in getting the
sign?
cofactor or getting the determinant?
The determinant.
determinant, you get this number the way it is, -1. And then you cancel the column and the row. The remaining numbers you put here, you're getting the determinant of these numbers. So you have
So no
-1.
following that Carol.
No, the row is still there. The plus is there, but the plus is invisible. Making it invisible means it does not affect the signs that are there. You multiply when you are done with the combination. So I have my -1, then I'll multiply. Okay, so this zoom will be cutting n times, so we can rest here.